The next question is, what is embeddings? Embeddings converts the text, images, or other data into numerical vectors that AI models can understand. They capture the semantic meaning of the content, not just the exact word. So similar content produces similar vectors, making it easy to measure similarity. Embeddings enable semantic search, retrieval-augmented generation, recommendation, clustering, and document retrieval. The vectors are stored in a vector databases, for example, FIAS, ChromaDB, Pinecone, for fast similarity search. So example here is the car is fast. So that will be converted into numerical vectors by using embedding model. So here you can observe 0.21 minus 0.45, 0.83, so on. It goes to 0.1. So just an example, okay? So that be an exact one. So these are some of the numbers which can be converted from text to numerical vectors. So here similar vectors, similar sentences, similar vector. The car is fast, the automobile is quick. So even though the words differ, the embeddings are close because they have similar meanings. So here in these two sentences, so the car is fast. Car is the word, and in the second sentence, the automobile is quick. So from these two sentences, so LLM model understand the difference between car and automobile. So then it is going to think it as both are same. So what vector databases have you used? So vector database used, one is ChromaDB. So stores embeddings plus metadata with persistent storage, and it performs the semantic similarity search for RAG applications and easily integrates with the LangChain and Streamlit. So second one is FIAS. What is FIAS? Facebook AI similarity search. So it is high performance library for vector indexing and similarity search, optimized for fast local retrieval of embeddings, and ideal for small to medium scale AI application. Why use a vector database? Okay, why we want to use a vector database? So we are going to use vector database to store the embeddings vectors efficiently, and so we are going to use this VB or VD vector database to retrieve the most semantically similar documents, and improves LLM response accuracy in RAG system, and it also supports the fast and scalable semantic search. So production alternative, what are the other production alternatives with vector database are Pinecone, Malvis, and Weaviate. The next question is, what is chunking? Chunking is a process of splitting large documents into smaller, meaningful text segments. That is called chunks. Each chunk is converted into an embeddings and stored in a vector database. So during a query, only the most relevant chunks are retrieved and sent to the LLM. Chunking improves retrieval accuracy, reduces token usage, and speeds up responses generation. Common strategies include fixed size chunking, recursive chunking, sentence-based chunking, and semantic chunking. So here you can observe in the example, the PDF document, it may have 100 pages. So LLM cannot go through all 100 pages at once. So what it will do is, it is going to chunk. That means it is going to split the large document into smaller and meaningful text segments. And that chunk one, chunk two, chunk three, not only one chunk, so it may go on. Okay, so how many chunks we need, that we are going to decide. And after that, it is going to generate the embedding. That means the chunk will be in text. Okay, so text segment, the text will be converted into numerical vectors. Okay, so that will be stored in the vector DB. So that's how the process goes on. So the important thing that we need to remember here is, the chunking is the process of dividing the larger document into smaller, meaningful pieces so they can be embedded, stored in a vector database, and efficiently retrieved for accurate LM responses in RAG application. The next question is, what embedding models have you used? So here I have used, so we need to say like this, OpenAI embeddings, so sentence transformers, Cohere embed, Google Vertex AI embeddings, Amazon Titan embeddings, and BAAI general embedding. So what is OpenAI embeddings? So here, text embedding, three small, so it is a fast, cost-effective, ideal for most RAG application. So another one is text embedding, three large. So it is higher, so it will use high accuracy for enterprise scale, semantic search, and retrieval. So when it comes to the second one, sentence transformer, So here, so we have two important models. One is all mini LM L6 V2, all MPNet base V2. So L6 V2, it is a lightweight, fast, and widely used for semantic search. And when it comes to the base V2, it gives high accuracy with richer semantic representation. The next one is the Cohere embed. It's an optimized for semantic search, classification, clustering, and multilingual application. So when it comes to the Google Vertex AI embeddings, so enterprise grade embeddings with multilingual support integrated into Google Cloud. So next one is the Amazon Titan embeddings, managed embeddings model available through AWS Bedrock for enterprise AI solution. So next one, same BGE. So it is a high performance open source embedding model widely used for RAG and retrieval plan. So here, what are the important thing we need to remember is there are several widely used embedding models, including OpenAI's text embedding, three models, sentence transformer, Cohere embed, Google Vertex AI embedding, Amazon Titan embeddings, and BGE. The choice depends on factors such as accuracy, latency, cost, multilingual support, and deployment requirements. What are AI agents? AI agents are intelligent systems that can reason, plan, make decisions, and perform tasks autonomously to achieve a specific goal. Unlike traditional LLMs that only generate responses, AI agent can take action, use the tool, and interact with the external system. So they use LLMs as the reasoning engine along with the memory, tools, APIs, and planning to complete complex workflow. AI agents can observe, think, act, evaluate, repeat until the task is completed. Common frameworks including LangGraph, LangChain agent, True AI, Autogen, and Microsoft Semantic Kernel. So here you can observe UI user request and it will go to the AI agent. So in the AI agent, there will be a reason and planning. And then after that, it uses the tools, APIs, database, and execute the action. And next it will come to the evaluate the result. And after evaluating the result, it will give the final answer. Okay, so this is the workflow of AI agent. So application involves the first one is customer support automation, personal AI assistant, multi-step workflow automation, IT help desk and DevOps, data analysis and report generation, travel and booking assistance. So the important points what we need to remember in this case of AI agent is an AI agent is an autonomous system. Okay, so an AI agent is an autonomous system that uses an LLM, memory, and external tools. So an AI agent is an autonomous system that uses an LLM, memory, and external tool to reason, make decision, and execute the task to achieve a goal with minimal human intervention. Next question. Difference between the chatbot and AI agent. So what is a chatbot? Chatbot is primarily answers users' question, but when it comes to the AI agent, it understands goals and performs the task autonomously. So chatbot generates the responses based on prompts. So AI agent, it is going to have a reasons, plans, acts, and evaluate the result. The chatbot usually limited to conversation. AI agent can use the tools, APIs, database, and external application. So chatbot reactive responds only to the user input. So AI agents are proactive, so it can make decision and execute multiple step workflows. Chatbot typically stateless or has limited memory. AI agents can maintain memory and context across networks. Example, in case of chatbot, it is FAQ. So frequently asked question bot, customer support chatbot. The example for AI agent is travel booking agent, coding assistant, autonomous business workflow agent, some of the things. So what are the key differences between chatbot and AI agent is chatbot focuses only on conversation and answering the question. When it comes to the AI agent, it focuses on achieving a goal by reasoning, planning, and taking actions using external tools. So in simple words, if you want to say, a chatbot acts as a receptionist who answers your question. AI agent as a personal assistant who not only answers your question, but also books the ticket, sends the email, schedules the meeting, and completes the task on your behalf. Important thing is a chatbot mainly provides conversational responses, whereas an AI agent goes beyond the conversation by reasoning, planning, using the tools and executing the task autonomously to accomplish a user objective. The next question is, what is Model Context Protocol? In simple words, we can call it as MCP. So MCP is an open standard that enables AI models to securely connect with external tools, databases, APIs, and applications. It provides a standardized interface so an LLM can discover and use the tools without custom integration for each application. MCP follows a client-server architecture where the AI application, that is client, communicates with one or more MCP servers, exposing tools and resources. It also improves interoperability, security, and scalability for AI agents. It is widely used for integrating AI with the systems such as GitHub, database, file system, Slack, Google Drive, and enterprise application. What are the benefits if you use the MCP? So the benefits are, so standard protocol for tool integration, reduces the custom API coding, and secure and controlled access to resources, enables the powerful AI agents and enterprise automation. The important points are MCP is an open standard that allows AI models to securely discover and interact with external tools, APIs, databases, and applications through a common interface, making AI agent more capable and easier integrate. How MCP works? So here you can observe. So user will give a request, and that request will go to the AI assistant, and from the AI assistant it will go to the MCP server, and in the MCP server it may go to the GitHub or database, API, file system, depends. Explain function calling. Function calling allows an LLM to invoke the external functions, APIs, or tools to perform tasks beyond the text generation. Instead of guessing an answer, the model identifies the required function and passes the necessary input parameters. The external function executes the task and returns the result to the LLM. The LLM then generates a natural language response using a function's output. So function calling enables AI applications to be accurate, reliable, and capable of interacting with real-world systems. So common use cases of function calling is, so weather information, flight and hotel booking, database queries, sending an email or messages, payment and order tracking. So important thing we need to remember in case of function calling is it is a capability. So function calling is a capability that enables an LLM to invoke the external functions, APIs, or tools by passing the structural parameters, allowing it to perform real-world tasks and return accurate context-aware responses. Explain hallucination. So hallucination occurs when an LLM generates incorrect, misleading, or fabricated information while presenting it as if it were true. It happens because LLM predicts the next token based on the pattern in training data rather than verifying it. Hallucination can include made up fact, incorrect references, fake citations, or inaccurate answers. This is a major challenge in enterprise AI, especially in healthcare, finance, legal, and customer support applications. Techniques such as RAG, function calling, grounding with trusted data, prompt engineering, and human validation help reduces the hallucinations. How to reduce hallucination? So this is also a very important question in the interview. How to reduce hallucination? So by using the RAG, Retrieval-Augmented Generation, we can reduce hallucination. And by connect to trusted database or API, and with the use of function calling for real-time information, and with writing clear prompt with constraints, and by validating the responses by using human review or guardrails. So by using some of these techniques, we can reduce the hallucination. So the important point we need to remember in case of hallucination is, so hallucination is when an LLM generates the false or fabricated information with high confidence because it predicts the likely text rather than verifying the facts. It can be minimized by using a RAG, trusted data sources, function calling, and proper evaluation. The same thing what we have discussed earlier. So explain LangChain. So LangChain is an open source framework for building the application powered by large language models. It simplifies the integration of LLM, prompt, memory, tools, vector databases, and external APIs into a single workflow. So LangChain provides reusable component to build a RAG system, AI agents, chats, and workflow. LangChain provides reusable components to build the RAG system, AI agent, chatbots, and workflow automation. It supports multiple LLM providers such as OpenAI, Anthropic, Google Gemini, Azure OpenAI, and open source model. It integrates with vector databases like ChromaDB, Fias, Pinecone, VB8, and Malvis. So what are the key features? Okay, so we can observe in LangChains are one is prompt management, second one is the RAG, third one is AI agent, memory management, tool and API integration, LLM orchestration. These are some of the key features we need to know in case of LangChain. The important thing, so the important point we need to remember here in this case is LangChain is an open source framework that simplifies the development of LLM powered application by providing the components for prompt management, retrieval, memory, tool integration, and AI agent orchestration. So what is LangGraph? LangGraph is an open source framework built on the top of LangChain for developing the stateful multi-step AI agent workflow. It represents the workflow as a graph where nodes perform the task and edges define the flow between those tasks. Unlike the LangChain, linear chains, LangGraph supports branching, loop, conditional logic, and parallel execution. It maintains state across the multiple steps, enabling complex, long-running agent workflow. It is ideal for building the autonomous AI agent, multi-agent system, customer support automation, and enterprise workflow. Why use LangGraph? So, stateful workflow, multi-step reasoning, conditional branching and loops, multi-agent orchestration, better control over AI agent execution. For this reason, you need to use the LangGraph. The important point we need to remember in case of LangGraph is the LangGraph is a graph-based orchestration framework built on LangChain that enables developers to create stateful agent with multi-step reasoning, memory, conditional branching, and tool integration. LangChain versus LangGraph. LangChain is a framework for building the LLM application, where LangGraph is a framework for building stateful AI agents using graph. So LangChain executes the task in a linear sequences. So where LangGraph executes the task as a graph with multiple paths, loops, and decision. So LangChain is best for RAG, chatbot, summarization, Q&A, and document processing, where LangGraph is best for multi-agent system, autonomous workflow, planning, and complex decision making. So LangChain is a simple to build and maintain, but when it comes to the LangGraph, it is more powerful but slightly more complex. The workflow includes in LangChain is, so we are going to give a prompt, it will go to the LLM, from the LLM we are going to get an output. But when it comes to the graph, okay, LangGraph, the flow is, so state, node, decision, next node, final output. So the process has become a little bit lengthy when it comes to it when compared to the LangChain. So simple analogy is LangChain is a recipe where each step is executed one after the another. So where LangGraph is a GPS navigation system that can choose different routes, revisit the previous step, and make decision based on the traffic. So when to use LangChain and LangGraph is, can use the LangChain for chatbot, RAG application, document queue, and summarization. And we can use the LangGraph for when the application needs reasoning, memory, multi-step agents, and conditional logic, and or long-running workflow. So the next question is, why Docker? So Docker packages an application along with all its dependencies, libraries, and runtime into a container. It ensures the application runs consistently across the development, testing, and production environment. It eliminates the common, it works on my machine problem, and containers are lightweight, portable, and start quickly compared to virtual machine. So Docker makes deployment, scaling, and maintenance much easier in cloud environments. What are the benefits of Docker? So it consists consistent environment across all stages, easy deployment on AWS, Azure and GCP. And if you use a Docker, so faster startup and lower resource usage is possible, and it simplifies the dependency management, and it works seamlessly with Kubernetes for orchestration. So the important points we need to remember in case of Docker is, so Docker is a containerization platform that packages an application with all its dependencies into a portable container, ensuring consistent execution across different environments and simplifying deployment, scalability, and maintenance. So here you can observe so how Docker fits into deployment. So application code can observe application code will be converted into a Docker image, and that will be stored in a container, and that will be deployed into a cloud. Okay, so this is how it is going to work. The next question is, why Kubernetes? Why Kubernetes? So Kubernetes is a container orchestration platform used to deploy, manage, and scale the Docker containers automatically. So it ensures high availability by restarting failed containers and distributing traffic across healthy instances. It supports the auto scaling based on CPU, memory, or user traffic. It also enables the rolling updates and rollbacks with minimal or no downtime. It simplifies the management of large scale production grade application. What are the benefits of Kubernetes? So if you use a Kubernetes, so automatic scaling can be possible. So self-healing is possible, and load balancing is possible, and rolling the updates and rollback, and high availability and fault tolerance, and efficient resource utilization. And efficient resource utilization can be possible if you use a Kubernetes. So what are the important things we need to remember in case of Kubernetes? It is an open source container orchestration platform that automates the deployment. But when it comes to the Docker, it is development, so testing and production. Okay, so here it is deployment. So scaling, load balancing, and management of Docker containers, making applications highly available, resilient, and production ready. So here you can observe the difference between Docker and Kubernetes. So the Docker, so here the Docker is used to create a package. So here you can observe this application code, and that will be stored as a container. Okay, so in a Docker, and here you can observe this is the container image. Container image. Build once, run anywhere. This is the motto, or this is the aim of a Docker. Build once, run anywhere. But when it comes to the Kubernetes, so Kubernetes is used to manage, deploy, scale, and monitor those containers. So it's going to monitor these containers in production. For example, here you can observe this is the containers from the Docker, and so the Kubernetes is going to deploy, and it is going to monitor in production. See, you can observe. So this is the node 1, this is a node 2, and this is a node 3. It is going to monitor and monitor the each and every container in the production. So what is the use of using Kubernetes? So we can automate and we can scale the size of a container, Dockers or containers, and heal if there is any problem or any fault. And you can manage each and every container. Okay, so in that way, the Kubernetes is different from Docker. And simple analogy is, so the Docker packs of application into a shipping container. But when it comes to the Kubernetes, it manages the thousands of those containers. You can observe here. So here it is a one container. When it comes to here, so here we have so many containers here. So Kubernetes manages thousands of those containers, deciding where they run, restarting them if they fail, and scaling them based on demand. So what is the key takeaway from this is Docker builds the container. Okay, so Docker builds the container, Kubernetes runs and manages it at scale. Okay, so this is a clear difference between Docker and Kubernetes, where Docker is just a container and Kubernetes is manages thousands of containers. Okay, so that's the difference. So from deployment, development to production. The next question is, why Docker if we have Kubernetes? Okay, so Docker is used to create and package the application into containers. Okay, so Docker is used to create and package application into containers, and Kubernetes is used to manage, deploy, scale, and monitor those containers in production. Okay, simple analogy is Docker is equal to packs the application into a shipping container, and Kubernetes manage those thousands of containers, deciding where they run, restarting them if they fail, and scaling them based on demand. That's what we have seen that in particular image, right? In the previous image. Deploying a GenAI application on Azure. This is also a very, very important thing if you are going for an enterprise things. So deploying a GenAI application on Azure. So the first step is develop the application. We need to develop the application where build the application using Python, Fast API, Flask, LangChain, and LLM APIs, and then containerize with Docker. So after developing the application, we need to containerize with the Docker, where it's going to create an image containing the application and its dependencies. Then we need to push to Azure Containing Registry. So ACR. ACR means Azure Container Registry. So where it's going to store the Docker image securely in Azure Container Registry. So after that, so deploy the application. So after storing securely, after storing the Docker image in the ACR, we are going to deploy the container to Azure Kubernetes Service, AKS. So AKS is short form for Azure Kubernetes Services for production, or Azure App Service for simple web application. So after that, we are going to connect the required services. Required services are Azure OpenAI for LLMs, Azure AI Search or Vector Database for RAG, Azure Blob Storage for document, Azure Key Vault for secrets and API keys. So the next what we are doing is so after deploying into the Kubernetes container to Azure Kubernetes, we need to monitor. So how Azure monitor and application insights for logging, monitor and performance tracking, and it also enables the auto scaling based on application load. Azure services commonly used. So what are the Azure services? So first one is Azure App Services, where it is going to host the web application, and Azure Kubernetes Services, which is also called as AKS. So where container orchestration is thing. So Azure Container Registry, where it's going to store the Docker images, and Azure OpenAI, so it is an LLM interface, and Azure AI Search, so it is an RAG and vector search, and Azure Blob Storage, document storage, Azure Key Vault, so security secret, and Azure Monitor and Application Insight is a service where it is going to monitor and logging. Okay, so these are some of the Azure services we need to know. Okay, so in the interview, if they ask what are the Azure services or web services, if you know, so then you need to mention all these things, or any few. So if you mention, that is more than enough. And what are the important point here is to deploy generative AI application on Azure. So we can, so I would containerize the application using the Docker and store the image in Azure Container Registry and deploying it to Azure Kubernetes Service or Azure App Services, and integrate the Azure OpenAI, Azure AI Search, Blob Storage, and Key Vault. Automate the deployment using GitHub Action or Azure DevOps, and monitor the application using the Azure Monitor and Application Insight. So next is CI/CD thing, CI/CD pipeline. So where CI stands for continuous integration and CD stands for continuous deployment. So CI/CD is a DevOps practice that automates the building, testing, and deploying application. So continuous integration. So here developers frequently merge the code into a shared repository where it is automatically built and tested. But when it comes to the continuous deployment, so after successful testing, the application is automatically deployed to staging or production. So this is a very important thing. Please remember this too, CI/CD. And CI/CD reduces the manual effort, deployment error, and release time. So common CI/CD tools include GitHub Action, Azure DevOps, Jenkins, GitLab CI/CD, and AWS code pipeline. So what are the benefits? Okay, so if you use CI/CD, so the faster and automated deployment is possible, and early bug detection is possible, and consistent, reliable release is possible, and it reduces the manual errors and easy rollback and version control. So these are some of the benefits we are going to get if you use CI/CD in the deployment okay, so in the production line. And what are the important points we need to remember in this case is CI/CD is an automated software delivery pipeline where CI builds and tests the code changes, and CD, continuous deployment, automatically deploys the validated application to the production, enabling faster, reliable, and consistent software releases. How do you monitor an LLM in production? So LLM monitoring in production is possible by monitoring the application health, so tracking the LLM quality metrics where accuracy, hallucination rate, relevance, broadness, and user feedback. So we are going to look into that and monitor the token usage cost. Okay, so LLM monitoring in production is by monitoring the token usage and cost, where input, output tokens, API cost, and overall inference cost will be looked into it. And by observing the log prompts, responses, and retrieval results. And and also we are going to and also by setting an alert and dashboard to detect the failures and performance degradation or unusual behavior. Okay, so by adopting these things, we can monitor the LLM in production. So common monitoring tools are Azure Monitor or Application Insight and AWS CloudWatch, Google Cloud Monitoring, and Prometheus and GraphNav, and LangSmith and Azure AI Foundry are OpenAI evaluation tools for LLM quality. And what are the key metrics we are going to follow in this case is response latency, API success rate, and token consumption and cost, hallucination rate, and retrieval accuracy, user satisfaction or feedback. So these are some of the key metrics we are going to follow when LLM is involved in the production. So quick technical one-liners. Okay, so it's a rapid revision, right? So from LLM to MCP, just observe here. So LLM is what? LLM is a transformer-based model trained to predict the next token, and RAG, retrieval plus LLM generation using external knowledge, and embeddings is a dense vector representing semantic meaning, and files open source is an open source vector, similarities such library, and LangChain is a framework for building LLM application, and LangGraph is the framework for stateful and multi-step agent workflow. And AI agent, what is an AI agent? AI agent, LLM with planning, memory, and tool usage, and prompt engineering. So it is a design of prompts, and fine-tuning is updating the model base with using the training data. And vector database stores the embeddings for semantic retrieval, and Docker is the containerization, and Kubernetes is the orchestrate and scale the mod containers, and Fast API is an high performance Python framework, and CI/CD automate the automated build, test, and deployment pipeline, and LLM OPS. Okay, so practices for deploying, monitoring, and governing the LLM, and MCP is a standard protocol for connecting the AI models to external tools. So, how do you evaluate the output of a generative AI application? So, how do you evaluate the output of a generative AI application? LLM output evaluation can be done by using the accuracy, so it is a response factually correct and based on trusted information. So relevance, does the answer addresses the user question and intent? So by using the groundness, so these are some of the things. So how we are going to evaluate the LLM output by accuracy, by relevance, groundness, hallucination rate, and consistency and completeness. And additional metrics we are going to use is latency, token usage, and cost, and user feedback. So here you can observe some of the workflow for CI/CD for Azure, CI/CD for AWS, and CI/CD for GCP. So here developer, so the developer is coding is the coding will be stored in the GitHub, and here in the GitHub action, so the Docker will build the image, and that will be stored in the okay, so Azure Container Registry, and that will be fed into the Kubernetes services, and from the Kubernetes services, it will go to the Azure OpenAI, and from the Azure OpenAI, it will go to the AI search, and then it will monitor, and it will be monitored by the Azure Monitor for any quick failure if it happens. And see, when it comes to the AWS, so developer will feed the GenAI application into the GitHub, and here they're going to have this code pipeline, and from here it will go to the code build, and from here it will go to the Docker, and from the Docker it will go to the ECR, and from EKS, and so then it will go to the Amazon Bedrock, and from here it is going to CloudWatch. So here it's going to monitor the entire thing if there is any thing or log, or if there is any failure happens. Okay, just like in case of Azure, we have Azure Monitor. Similarly, we have here CloudWatch in case of AWS. Next, come to the GCP. Here, developer will push their application into the cloud build, and from there, so it go to the artifact registry, and it will run in the cloud, and then it will go to the Vertex AI, and here it is going to all the things will be monitored in case of cloud monitoring. So here you can observe Azure Monitor, CloudWatch, and cloud monitoring. These are some of the things it is going to take care, or it is going to look into the entire things. Okay. So these are some of the workflow for Azure, AWS, and GCP. Just have a touch of it before going into the interview. And can CI/CD also deploy infrastructure? Yes, CI/CD can also deploy infrastructure by using a code. So IAC, infrastructure as code. So CI/CD pipelines can automate the deployment of both applications and cloud infrastructure. And infrastructure is defined as the code using tools like Terraform, Azure by AWS Cloud Formation, or Pulumi. Okay, so the pipeline provisions cloud resources automatically before deploying the application, and this ensures the consistent, repeatable, and version controlled infrastructure developments. And it also supports the rollback automation and faster releases. And here you can observe the end-to-end GenAI application life cycle. So what is the first step is business requirement. Then they are going to choose the use cases and select the suitable LLM. And by using the suitable LLM data collection, they are good for the data collection and pre-processing. After that, chunking. So embedding generation. You all know by this time, right? What do you mean by chunking and what is embedding generation? Just explain, okay? So dividing the document into smaller pieces, and that will be converted into numerical vector representation, and then it will go to the that will be stored in the vector database, and the stored vector database will be pushed into the so we are going to use that RAG application. Okay, so for continuous upgradation, and then prompt engineering. So we are going to give an input, and based on that, it's going to testing and evaluation is done, and then it will go to the fast API development, and then it will go to the Docker container. That means the entire code will be converted to image, and that will be stored in a container, and that will be pushed into the CI/CD pipeline. And from the CI/CD pipeline, it will be stored in the cloud deployment, and it will go to the cloud deployment. And from there, it is going to monitor the entire things. So this is the entire end-to-end GenAI application lifecycle, starting from business requirement to the monitoring and LLM OPS. So that's the thing. Okay. So thank you and all the best for your GenAI developer interview. So if some of the question, if you get in the interview, and if it is helpful for you, if it helps you in the interview, okay, so just comment. Okay. So if you like this video, please share and subscribe. Okay. So thank you.